the equation of a straight line. Welcome to episode 2 of our coordinate geometry series. In this video, we are going to calculate the equation of a straight line, either given 2 points or the gradient and a point. Let's jump straight into it. What is the straight line? First of all, a straight line, it's something that looks like this. You have your Cartesian coordinates like that, and then there is a straight line like that, and then you are required to write the equation of this line in the form y is equals to your mx plus c. Just a reminder, for the equation of a straight line, the general equation y is equals to your mx plus c, the value m gives you the gradient. This is the gradient, the steepness, or rather the measure of the steepness of that line in relation to the horizontal axis. Now, the value c, this one is nothing but c will give you the y-intercept. This is the y-intercept, or rather the y-cut. Now, let's jump straight to examples on this video. Example number 1. You were given 2 points. Whenever you are required to calculate the gradient, the equation of a straight line given 2 points, all you need to do is to first calculate the gradient using those 2 points. From our previous video, we've covered how to calculate the gradient. So your gradient m is going to be equals to your x, your y2 minus y1, and this is over your x2 minus your x1. Pick something here. This is y1, like that. Now let's label these points, point A and point B. We can modify this to have your ya, because you were given the points as A and B, so that's ya minus yb, and then your xa minus xb, and this is going to give you the gradient. So this is equals to, what's the value of y at A? The value of y at A is -3 minus the value of y at B is 4, and then let's divide by the x values. X at A, that's 2, minus x at B, that's 7, and then your -3 minus 4, this is going to give us a -3 minus 4, that's a -7 over, then 2 minus 7, that's giving us a -5. So basically that's your gradient, which is -7 over -5, which couldn't be written as 7 divided by 5. Now, there are 2 ways that we use when once you have your gradient is equals to 7 over 5 and a point. The point, we can use any of those 2 points there. Suppose we're using point A, your 2, -3, that's a point. Now let's try to find the equation. The first method is by substituting directly into the general equation. Y is equal to your mx plus c. Now let's substitute the value of y. We have a -3. This is equals to the value of m, which is the gradient, that's 7 over 5, and then plus times x. What is x? It's 2, and then plus c. Let's try to simplify here. You have your -3 being equals to 7 on 5 times 2. That is going to give you a 14 on 5 plus c. Then if you subtract 14 on 5 from both sides of the equation, 14 on 5, these ones are going to get cancelled out. This one cancels that, and then you are left with -3 minus 14 on 5. This is equals to c, and this is going to give you a -29 over 5. This is the value of c. Now go back and substitute the value of c in this equation. In this equation, you substitute the value of m, which is the gradient, and also c. Then you will have calculated the equation. Let's go ahead and do just that. Your y is equals to, what was our gradient in this case? The gradient was 7 over 5. Multiply by x, then minus 29 over 5. That's the equation, which can also be written without a denominator as multiply throughout by 5. Your 5y will be equals to your 7x minus 29. That's the equation of the line. Let's also calculate this same equation now using the other point. And still the same method, which means we have our gradient being equals to 7 on 5. And then now the point, it's no longer the 2 on 3, it's 7, 4. We want to find the equation. Still, y is equals to mx plus c. Value of y is 4. And then the value of the gradient, 7 on 5. And then times our x, it's 7 plus c. And then this is going to give you 4 equals to 7 over 5 times 7, that's 49 on 5 plus c. And then from there, subtracting 49 from both sides, you are going to get your 4 minus 49 on 5. This is equals to c. And then from there, you have your c being equals to still your 29 on 5, which is negative. Now let's substitute. Then you have your equation as y being equals to 7 over 5 x minus 29 over 5. That's your equation of the line. So the bottom line here is, once you have the gradient, you are free to use any of the 2 points to calculate the same equation, and you are going to get the same result as we got here. Let's move on to example number 2. For example number 2, we are given the gradient and a point. Now, for this, I'm going to use the same method we used before and also introduce you to another method you can use to calculate the equation of a straight line. The method we've just used said your y is equals to your mx plus c. Now let's go and substitute. The value of y is this one here, and then the value of x is this one there. The gradient is this one here, which is negative 4. Let's go ahead and substitute. Value of y is 5. This is equals to the gradient, it's negative 4 times your x. Your x, it's actually 0, and then plus c. So you have your 5 being equals to negative 4 times 0, it's 0. 0 plus c gives you c. So the value of c in this case is equals to 5. Substituting back into the equation, y is equals to mx plus c. Your m is negative 4x plus the value of c that we've just calculated with is 5. So that's your equation. Alternatively, to calculate the equation of a straight line, this is the method you might be interested in using. What's this method saying? This method is saying it's y minus your y1 being equals to your m into x minus x1. The difference between these two methods are, for the first method, you're substituting twice. First, you substitute and find the value of c, then substitute back to find the equation, and then this you substitute once and get the answer there and there. Let's go ahead and substitute. So what we actually substituting, it's y1, m, and x1. So your y1 and x1, that's the coordinate that you will be given. For example, we are given 0, 5. So your 5 is actually y1, and then your 0 is actually x1. Then the gradient, it's negative 4. Let's go ahead and substitute there. So we have your y minus y1, that's a 5. This is equals to the gradient negative 4 into x minus your x1. What's the value of x1? That's 0. Let's go ahead and simplify this. You have your y minus 5. This is equals to x minus 0, it's x, this one here. X minus 0 gives you x. X times negative 4 gives us a negative 4x. Then if we subadd 5 on both sides of the equation, you are going to get that your y is actually equals to negative 4x plus 5. Next example. In this example, you were given the line, and then you are going to extract the coordinates by yourself. This coordinate is supposed to be a negative 5, 0, negative 5, 0. And then this one, it's supposed to be a 0, 5. Now, let's go ahead and do the needful. Let's just rename this one as 1, this one as 2, so that we can easily say this is our y2, this is our y1, and then similarly for the x, this is your x2, this is your x1. Since we are required to find the equation, first things first, we need to calculate the gradient. So the gradient is equals to y2 minus y1, and then this is over the x2 minus x1. Let's substitute y2 as 5 minus, then y1 it's actually 0, and then on the other hand your x2 is actually a 0 minus then the 5 there. It's minus a negative 5, this one here, and then this is going to give you 5 minus 0 is actually a positive 5, and then 0 minus negative 5, it's actually a positive 5. So we have 5 on 5, which is 1. That simply tells us that the gradient of the line we are dealing with is 1, and the point can be anyone. So as we have learned two methods for calculating, we will use one for one point and then the other for the other point. So we're having a gradient of 1, and then a point is negative 0, negative 5, 0, and then we also have the gradient 1, and then the point in this case is actually a 0, 5. So what we're actually going to do here, we are going to use y equals to mx plus c for this one, and then we're also going to use y minus y1 equals to your m into x minus x1 for the second one. The aim is to try to expose you to both the methods for calculating the equation of a straight line. Let's go ahead and do just that. Using your y being equals to your mx plus c, here let's substitute the value of y is 0. This is equals to your gradient, it's 1 into your x, it's negative 5, then plus c, and then this is actually a 0 being equals to 1 times negative 5 is actually a negative 5, then plus c, and then if you add 5 on both sides, you are going to get that your 5 is actually equals to c. And then from there, substituting back, let's substitute back, you have your y being equals to the gradient, it's actually a 1 multiplied by x, then plus 5. Then 1 times x is actually x, so we can remove that one. Then that is our equation. Let's come back to this one here. We said y minus y1, this is equals to your m into the x minus your x1. Now let's go ahead and substitute here. You have in your y being equals to the y1, the value of y here, it's actually 5, and then this is equals to your m, which is the gradient, that's 1 into the value of x minus, and then the coordinate of x here is actually 0, so we need to put 0 there, and then your x minus 0, x minus 0 is actually x, so you're having your y minus 5 being equals to that x times 1, that's actually x, and then if you add 5 on both sides, you are going to get that your y is actually equals to your x plus 5. And basically that's how you find the equation of a straight line. You're either going to use your y is equals to mx plus c, and then for this one you are going to substitute y and then also substitute m and x, then find the value of c, and then substitute the value of c back into this one, whereby you also have to substitute the value of m. Alternatively, you can use this method here, this one, whereby here you are just going to substitute your y1 and your x1 and also the value of m, and then playing around with the algebra, you are going to get the correct equation. Thank you for staying tuned in this video. Hope to see you in the next one.